I'm just going to change it a little bit. Alright, so you have this problem. Now this is for those that are really decent at the laws of exponents. This is not for people that are still having trouble with the laws of exponents. But I want to show you another option that the rules actually allow you to do. The trick is, well, obviously 14 over 7, that'll just give you 2. But the trick with the variables, if you want to just get the answer where it belongs, the first step, rather than worrying about getting an answer and then moving it to where it belongs. Take the smaller power through the fraction bar towards the other variable. Now, if you're looking at the x's, which one is the smaller power? -5. So what you do in your head is you take the -5 and you bring it to the top and it becomes +5. And what that does is it guarantees that the x's are going to end up in the top. They're going to end up in the top. So this becomes 2. You're going to get x to the, when that comes up, it becomes +5. When you add it to -3, it becomes +2. Now, when you look at the y's, which one's bigger, or I'm sorry, smaller?
-3.
The -3. So you're going to take that one and drag it down. So it becomes +3. Then you have y to the 4th times y to the 3rd is y to the
7.
But that's in the bottom because you brought it down. And then you raise it to the -2. And in that way, when you do that type of shortcut, the x's and the y's are going to end up on the correct side, and they are both going to be positive, without a doubt. That way you don't have everything on the top, and then next step you have to drag something to the bottom. So the trick is you take the lower exponent, you just kind of mentally drag it through the fraction bar towards, I'm sorry, the smaller exponent, drag it towards the other one. That guarantees your answer is always going to be positive. And then what does this negative do? Flip the fraction, so you get y to the 7 over 2x squared raised to the 2nd, and then you just can square everybody. So you get y to the 14th over 4x to the 4th. And there's your answer.
So what happens if the x is, the very top x cubed is positive and the x to the 5th is positive?
Which one's smaller?
The 3 is.
So then you would bring this one down.
Then now you're subtracting, right?
And you get 1 over x squared. No, you're subtracting because that becomes a -3, so 5 minus 3 is 2, but the answer ends up in the bottom, the direction that you went in.
And if it was vice versa, bringing it up, same thing.
And then the answer would end up at the top. That way you don't have to worry about flipping it the next step. So it's actually just getting rid of one step. But it's a nice step to get rid of. Anytime you can avoid negative exponents. Any other major questions?
Do you have another email address?
I have many email addresses. There's this one.
Well, which one did you check?
This one, of course.
That's the one.
Yeah, and then there's this one.
Chlorine 69 at Hotmail.
And if you send it to this email address, it gets sent to my other one. I have it forwarded. Yeah, so if you send it to this one, it goes to this one. I have it forwarded. So when did you send it?
Like 5 o'clock.
I haven't checked since then. Is that
Wow.
late? No, I checked last night. I'll look again.
I found it out.
The email address has been strange since the hurricane. People have told me that they sent me email. I'm like, no.
Okay.
So I'll check again.
I don't need it.
All right, no problems with solving equations?
Can we do number 35 on page 63?
Page 63. Number 64, 35. Ugh. 35. 5 minus 2x over 7 equals 1 minus x minus 4. Alright, what did you do first?
Get rid of the fraction.
Alright, so you
Multiply by 7.
multiplied everybody's by 7. So 7 times 5 is
35.
35. 7 times this term here would give you 2x. Because the sevens are going to cancel. If you multiply, if you multiply this by 7, it'll cancel, and you're just left with 2x equals 7 times the 1.
7.
Oh, 7. Minus 7 times x minus 4 is 7 times x minus 4. You can't get rid of the parentheses unless you distribute, and it's really not a good idea to distribute because that's a minus, and most people screw up minuses and negatives. All right, next step is, can I do 7 minus 7?
Not yet.
Please don't. Copy it over, distribute the negative 7. Make sure you call it negative 7. So you get 35 minus 2x is equal to 7
7x
minus 7x.
minus 28, or plus 28.
A negative times a negative is a positive, and you're going to get 28. Okay. Next step.
Combine like terms.
Combine like terms. Nothing on the left. On the right, 7 plus 28.
35.
35. Minus 7x. Okay. Now what?
Subtract 35.
No. You
I
can.
mean, not the
But
very-
concentrate on the x's first. So either work with the 7 or the 2. Okay. Add 2. So you add 2x to both sides. And then this becomes 35 because that turns into a big fat 0. Make sure this turns into 0 because if it doesn't, something's kind of wrong. So 35 is equal to 35 minus 5x. Negative 7 plus 2. Now what?
Subtract the 35.
When I subtract the 35, what's going to happen?
Gonna cancel out.
So what's left on the left? 0 is equal to
Negative 5x.
negative 5x. So what does x have to equal without doing any calculation whatsoever?
0.
It has to equal 0 because the only way you're going to get 0 over here is if this is multiplied by 0. Any other number, you'd have some number over there. So x is guaranteed equal to 0 by the 0 multiplication problem.
On mine, on that my last plus, it would give you like 3 answers for a question like that. It will give you a solution, no solution, or like all real numbers.
Yeah.
So it'll be all real numbers.
This one? No,
Yeah.
x equals 0.
This would be 0?
Yeah.
Okay.
That's a number. When you get no solution, you get something that looks like this. This is impossible. When you get all solutions, you're going to end up with something like this, because that's always true. So all solutions, no solutions, one solution.
Okay.
Okay. These you don't see too often. The identity, equality, and the
There was
inconsistent.
a few of them on that last plus yesterday.
I know.
Okay.
I put one on there by mistake. But that's okay. I mean, it's something you have to see. Because it does happen every once in a while. All right, any other problems?
Don't we do with a lot of part on the decimals?
Decimals?
Yeah.
All right. You want me to just make up one, or?
Yeah.
Okay. 0.25x minus 0.25. Not that I would care if you put the 0 or not. 0.3x plus 0.2 equals 0.15x plus 1.2. They're just decimals. Oh, shoot. I just wrote over everything I just wrote. All right, so what should you do?
We'll get rid of the parentheses.
Distribute. So when you distribute, you're going to take this negative. Well, would you get rid of parentheses first?
You can make it
Multiply by 10.
Well, it's your choice. Now, if you have a calculator handy, you can leave it in decimals. That's not going to hurt you. Just make sure you do all your calculations on calculator because people are weird with decimals. Or you can multiply everything by
100.
100, because this is 25 hundredths, and this is 3/10. So you always go for the smaller value, which is 25 hundredths. So you can multiply everybody by 100. Now, how many terms are on the left-hand side? I love asking this question.
3.
2. There are 2 terms on that side.
Okay.
Terms are separated by addition and
I
subtraction.
think that in multiplication.
Multiplication you can't have a term under. So the 2 terms you have are this one and this one. How many terms are on the right-hand side? 2. So when you multiply through by 100, you're going to multiply 2 things on this side and 2 things on that side. The problem that people have is they see 4 terms over here or 3 terms over here, and they multiply by 100 3 different times. But you're only supposed to do it twice. So I'm going to multiply this guy by 100. I'm going to multiply this guy by 100. And I'm going to multiply this guy by 100. And I'm going to multiply this guy by 100. It's technically distribution on both sides. All right, so what's 100 times 0.25? 25. So this is 25x minus what's 0.3 times 100?
30.
30. Parentheses x plus 0.2 is equal to 15 x plus 120. So the numbers got a little bit bigger. Now notice that 0.2 is still there. That sometimes could be good, that sometimes can be bad, but definitely don't multiply it by 100 because it's inside of the parentheses, multiplying on the outside. All right, what should I do next? Distribute. So this is 25x minus 30x, and nicely enough, negative 30 times 0.2 is 6. 0.2 is 1/5.
Oh, yeah.
1/5 of 30 is 6. So what kind of 6?
My energy drink kicked in.
Negative 6. And then the other side, of course, is 15x plus 120. Nope. All right, what should I do on the left?
Combine like two.
Which would be the x term. So that leaves me with negative 5x minus 6 is equal to 15x plus 120. All right, next.
You're gonna add the 5.
You can add the 5x across and you end up with 20x plus 120. Subtract 120. So this becomes negative. You want me to show it? Negative 126 is equal to 20x. And then finally, divide by 20. X is going to equal a negative number.
6.3.
More than likely, the lab would want you to write it as a fraction. So what goes into 126 and 20? The only number I can think of is 2. 2 goes into 126 63 times. 2 goes into 20 10 times. So that's the best answer you're going to get.
It'll take a decimal on that.
Oh, will it take a decimal? Okay, so negative 6.3. Negative 6.3. One thing to notice, and I was watching your work in the lab, and a lot of people shifted everything to one side and forgot to write 0 on the other side. They were losing equals. Make sure your equal sign lines up all the way down. That way you don't lose it. That way everything stays left side and right side. You start floating that equal sign, it's really hard to follow your work and seeing where you're going. But if you keep that equal sign going straight down the middle, it's a little bit easier to see. If you move everything from one side away from it, you better leave a 0 behind. So if I took these 2 pieces and I shifted them to the left-hand side, these 2 pieces here, if I shifted these to the left-hand side, this side better become to the right-hand side. This side should become a 0. There always has to be the equal sign, and it has to be equal to something. So if you move everything, put 0 there. There's nothing wrong with that. Sometimes you get lost and you start floating things the wrong way. And if you float everything one way, just make sure the other side's equal to 0. All right. Any other major problems? Especially with those literal equations. You know, solving for a variable and a bunch of variables. Those were easy, weren't they? for the most part? Maybe? 49. What page? Oh, you're still back in regular equations. 49.
Emma, you got the,
Why?
I got the work right here.
Oh, from someone else? Nothing, no problems with literal equations? Did I give you homework out of literal equations? I thought
Yeah, you did. I didn't do it.
you didn't do it. I guess I'll wait.
Just a
till-
practice problem.
Oh, by the way, the test is guaranteed next Friday. Guaranteed.
Guaranteed.
So, I'll finish up the chapter today. We'll have a lab on Tuesday. Review a little bit on Wednesday. Another lab on Thursday, getting ready for the test, so I assume everybody's going to get an A. I've had a whole week of review, you should be perfectly fine. Alright, so the last stuff, oh, I just stop my nose, is actually about the same as what we just, well, the same problem as we just did, except for one small difference. And this is 2.6, I think. Inequalities, or linear inequalities, or linear inequalities in one variable. But basically, it's the same type of solving that we've been doing, except we throw in a little inequality stuff. So, for instance, when you write something like this, what does it mean?
Less than or equal to.
All the numbers that we're going to be talking about are greater than or equal to 4. If we were going to draw this on a number line, because you have to be able to graph these things, the only things that I'll be looking for is you'll need a 0. 0 is always the separator between the positives and the negatives. So if your arrow points to the right, it's the positive side. If your arrow points to the left, it's the negative side. Usually if it points to the right, the positive side, that is greater than. And if it points towards the negative side, that must be... Are you awake? If this one's greater than, this one is less than. Okay. So when we do greater than or equal to 4, the other number that I care about is the 4. Now, the book is going to have you draw the arrow on top of the number line. But if you have a pencil and you're drawing on top of a pencil mark, it's really hard to see. So I highly suggest that you draw your arrow above. So this would be greater than 4. Now how do I indicate that it's equal to 4? A solid circle. So you'd have a solid circle here, and then it would be pointing towards the more positive numbers. And that would be greater than or equal to 4. You remember this, right? Yeah. Just a little reminder. When you get to college algebra, we change all this.
I think they changed algebra since high school.
If you have x is less than -3, you put your 0 here, you put your -3 here. Which way is the arrow going to be pointing?
To the left.
To the left. So you'd have to the left, and you'd have what kind of circle? Open circle.
Wide open.
Because it's
Oh,
not
not
equal
equal
to. It's just strictly less than. All right. So that's the basics of inequalities. Then I have to talk about some of the little subtleties. Subtlety number 1. If you see an inequality in this order, you have -5 is less than x. Don't leave it that way. Because if you leave it that way, confusion will get you in the end. So the best thing to do is to take the inequality and flip it. So the x is always on the left, and the number is always on the right. But if I put the x over here, what happens?
You flip the sign.
You have to flip the sign. Think of it this way. If 2 is less than 5, and I put 5 first and 2 second, the sign has to flip because 2 is less than 5, but 5 is greater than 2. So if you ever get confused with inequalities, just use numbers and see what happens. There's a special case for that. So this becomes greater than -5. So when you draw your number line, here's 0, here's -5 someplace over there. And which way is the arrow pointing?
To the right.
To the right. So there's our solution. What kind of circle?
Open circle.
Open circle because it's not equal to
Because the gator mouth always eats the bigger number. Right?
gator mouth. One little comment. Where does the symbol greater than come from? Why do they use the symbol?
Make confusing.
Pac-Man. Draw like a Pac-Man, you know. Pac-Man. Anybody know where the symbol comes from? It's easy to see. If you draw an arrow, what's the symbol at the very end of it?
Arrow.
Greater than. And if you draw this arrow, what's that symbol? Less than. That's where they come from. They're from literally the arrows. So when X comes first, that arrow is pointing in the right direction for your number line graph. It's pointing to the right. And when you do less than, it's pointing to the left. It's literally off the head of the arrow. That's where those symbols came from. All right. Solving an inequality. Well, if you have 2 is less than 5, and I subtract 3 from both sides, does it keep the inequality?
Yes.
Yes, and not only does it keeps it perfect. For instance, if you had a scale, and this side had 2 kilograms, well, 2 pounds on it, kilograms, nobody understands kilograms. This side had 2 pounds on it, and this side had 5 pounds on it. You subtract 3 pounds from both sides, the scale would stay exactly the same off-balancedness. It wouldn't change at all. It wouldn't lean a little bit less or more. It would stay kind of equivalent. So this is called the subtraction property of inequality, which is exactly the same as the subtraction property of equality. Whatever you do to the left, do the same thing to the right. Same thing with addition. The only caution I have with inequalities and whatever you do to the left is exactly what you do to the right, is this. You know that 2 is less than 5, right?
Yes.
If you multiply both sides by -1, this side becomes -2, this side becomes -5. What happens to the inequality when you multiply by a negative?
Flips.
You flip it. Why? Because -2 is greater than -5. -2 is further to the right than -5 is on a number line. So when you multiply and or divide by a negative, you have to flip the sign. If you subtract, that doesn't do a darn thing. Subtraction, addition does not do a darn thing. Neither does multiplying by a fraction, dividing by a number, multiplying by a number that is not negative. So multiply or divide by a negative, you must switch, flip, inequality. That's the only difference. You have to be really, really cautious of that. When you multiply or divide by negative, you just have to kind of go ding dong in your head and figure out that you just have to flip that inequality. All right. So, what are we going to do with these things? What does the book do to them? I don't want to go too crazy on you. I follow the book because if I don't, I'll be teaching you like pre-calculus kind of math. I gotta constrain myself a little bit. We'll start off easy. This is just number 30. 5x minus 1 is greater than 29. Something simple. Now, they don't ask for the number line graph, but I'm going to do one for each of these just to get you used to it. What would you do first?
Solve for x.
You're going to solve for x, so you would add 1. Now the inequality becomes that point where you want to drop that inequality straight down. You don't want to be moving it left or right. So add 1 here, and you get 5x plus 0 is 5x is greater than 30. Next step, divide by 5. So you're going to get x is, well, 6 over here. Why would you say less than?
It's greater. When you divide, oh, a negative.
Multiply and divide by a negative. That's the only one you worry about. If you just divide by a number, this stays greater than. So if you do a number line graph, real quick, here's 0, here's 6. What kind of circle above 6?
Open.
Open. Which way is the arrow pointing? Same way that arrow's pointing. To the right. As long as the variable is first, that is true. If the number is first, I implore you to switch it around. Get that variable on the left-hand side, number on the right-hand side. All right, now that I know what kind of questions I can ask you, here's an example.
There you go, messing around with the fraction.
I have to throw some fractions in there. How would you rewrite it? Do you like my 1/3 thing, Majiki? Yeah. Change that to a 1/3, change that, well, leave that alone. Change that into a 1/2.
Yeah.
So this becomes 4 minus 1/3 parentheses 2x plus 1 is greater than or equal to 2/3 plus 1/2 parentheses 5x minus 1. Get rid of those long bars and just realize that they are a grouping symbol, that they do turn into parentheses. All right, what would you do next?
Find the least common denominator.
You could distribute, but I would highly suggest you go for a common denominator. As long as you understand how many terms are in the left?
We got
2. How many terms on the right? 2. So you're only going to multiply by the common denominator twice on the left and twice on the right. No more, no less.
Did you have to do that though?
What?
Do it,
You can distribute first. But when you distribute, you start having to working with fractions right away. I personally like getting rid of them right away.
I'm saying so the second equation is the same as the first, still, right?
What do you mean?
Yeah.
It's still the same. You just,
She's saying when you put that 1/3.
yeah.
Oh, you could work with it from up here.
Okay.
That's fine. But some people don't see that that's 1/3. I saw people doing distributed at the top and bottom by the common denominator. And this way it forces you just to look at the first number. That's the only reason I like it. So the common denominator is 6. So I multiply here by 6, here by 6, here by 6, here by 6. 6 times 4, 24. 6 times 1/3, 2. Parentheses 2x plus 1. Leave that alone. Don't try to do 2 steps at once. That'll always get you in trouble. Greater or equal to. That doesn't change yet. 3 goes into 6. 2 times 2, 4. 2 goes into 6. 3. 3 times 1 is 3. 5x minus 1. Now everything is a nice whole number. Well, at least integer. All right, distribute. So this becomes 24 minus 4x.
plus 2. Well, minus 2 because it is.
Negative 2 times positive 1. Negative 2. Greater and equal to. 4 plus
15.
15x minus 3. Okay. Next up. Combine like terms. 24 minus 2. 22 minus 4x is greater or equal to 4 minus 3. 1 plus 15x. Getting there. Next step.
Add 4.
If we add 4 from this side to this side, this becomes 19x. So this is 22. Is what? Less than, greater than? There's no such thing. Actually, there is something called this. Does anybody know what that symbol can be replaced with? If you're less than, greater than? Same thing as not equal. You can't be both, so you can't be equal. All right. Is greater than or equal to 1 plus 19x. Okay. Now what? Subtract 1. This becomes 21 is greater than or equal to 19x. And then finally, last step, divide by 19. Now here we have 21 over 19 is greater than or equal to x. And I'm telling you, don't leave the number first because most people don't read that the correct way. Switch it around and get the variable first. If you switch it though, you're going to get x is less than or equal to 21 19ths. And that would be your answer. That way the arrow was pointing to the left. We're talking about numbers that are less than about 1. 21 19ths is about 1. A little bit bigger.
So if we were done a graph, you want 20 over 19 on the graph?
21 over 19, yeah. You know, you draw your little graph. Here's 0. 21 19ths is over here. The arrow is pointing to the left. It's equal to, so you're going to have a solid circle and go off that way. Notice again that that inequality goes straight down the problem. I don't shift it left or right. That way I can always tell what's the left-hand side and what is the right-hand side. If you keep it nice and organized, you'll avoid a lot of silly mistakes. That's your whole goal because everybody's going to make mistakes. So you want to try to avoid them and you try to come up with techniques that stay away from making more mistakes. How much harder can I get? Oh, can't get that much harder. Try this one. I'm going to make up one. I have no idea what the answer is. We'll have to figure it out later. Fractions again? Yeah, fractions. 3/4 x minus 1/2 5 minus 3x plus 1 is less than. I know. It's horrible. 1/4 minus 3x 2x plus 1.
I have a question.
This one right
When
here.
you're finding the lowest common denominator,
Uh-huh.
and you said that, you know, one side's got, what, 3 terms, the other side's got 2 terms?
Very good. 3 terms on the left, 2 terms on the right.
So that it don't matter how many terms are inside?
Nope.
Just
All that happens is, because there's 3 terms over here, you're going to multiply the common denominator 3 times, and then on the other side just
So
2
it
times.
doesn't
I don't
have
want
to
them to be equal.
Okay.
They don't always have to be equal. That's why I wrote this one, because the book had equal ones. I wanted to try something. Now, I mean, literally, this is the same thing as solving a regular old equation. You just have to be cautious with that inequality for flipping purposes and for multiplying by negative purposes. All right, what's the common denominator? 4. So you're going to multiply each one of your terms by 4, including this 1 way over here. If you forgot that 1, he really does need that 4, even though he's not a fraction. This guy gets it, and this guy gets it. That's it. Nobody else gets multiplied by 4. Not inside those parentheses, especially. What are you giggling about? Did you multiply inside? She did. 4 times 3/4. 3x. The 4's are going to cancel. Multiplicative inverses. 4 times a half. 2. And then 5 minus 3x is not going to change. 4 times 1. 4 is still less than. I'm multiplying by a positive 4. Nothing's changing. 4 times a fourth. 1. 4 times 3 halves. Negative 6, yeah. And left behind, of course, is 2x plus 1 on the top. So that gets rid of all the fractions. Anybody make a mistake there? If you made your mistake there, the rest of it gets really bad afterwards. What should I do on the left-hand side? Distribute this -2 to these two numbers. Make sure you carry that negative to that second one. So this is 3x minus 10 plus 6x. Leave that 4 alone, less than 1 minus 12x minus 6. Now things are really spread out. Lots of letters, lots of numbers. You want to condense it on both sides. So on the left, there's actually an x and an x and a 10 and a 4 that need to come together like terms. 3x plus 6x. 9x. Negative 10 plus 4. Negative 6 is less than. Right-hand side is just 1 minus 6. Negative 5 minus 12x. Or negative 12x minus 5. I don't care which way you write it, as long as you get the pieces. Now we're down to what's called a standard form. Kind of like that ax plus b equals cx plus d type of situation. What do you move next? Which one?
12x.
I would do the 12. If you did the 9, it's not a big deal, but add 12x to both sides. And what does that give us? 21x minus 6 is less than negative 5 plus 0. Add 6 and you get 21x is less than 1. So x is less than, divide by 21. So it's 1/21. Who had it? Tori had it? You had it. Anybody else? Did you find your errors? That's the important part. If you find your errors, then you can go through this process again and see if you can do it on your own. So, problems like this. You did it wrong the first time around. You know that you had an error. Go back and find it and do it again until you get it right. Because you will see this on the test again. Not maybe this horrible, but something very similar to it. Which way would the arrow be pointing for this?
The left.
To the left, because that arrow is also pointing to the left and the variables first. So if you end up with that variable in the right-hand side, make sure you flip it so you at least know how to draw the number line solution. Here's 0, here's 1/21, and you're going to have an open circle, and it will be going to the left. All right.
My confidence is like up here when I walk in here. And then after I leave here, I feel like an asshole.
One quick one then. There's a quick. Solve that. You have exactly 3 minutes.
3? That's so sad.
It's a very simple problem. All right, here we go. We don't have any more time. It's like time to leave. Common denominator.
6.
6. Some people were using 12. That's perfectly fine. But I'm going to go with 6. So multiply here by 6, multiply here by 6, multiply here by 6. Let's see if you all got the right answer. 6 times 4. 24. 3 goes into 6. 2. 2 times 2 is?
4.
Negative 4x is greater or equal to, the 6's here are going to, and you're left with 7. Now if you multiply through by 12, your numbers are going to be bigger, but 2 times what those are. So you would have 48 minus 8x greater than or equal to 14. But that's okay, that's perfectly fine. You'll still get the same answer. Next piece you should move,
24.
the 24, so you subtract 24 from both sides. And you get negative 4x is greater than or equal to
Negative 17.
negative 17. It's greater than equal to, right? Because even though you're subtracting 24, that's not changing anything. But here, you're going to be dividing by negative 4. So this is x by itself, 1x, is less than or equal to, because you've divided by a negative, so you have to flip the inequality. Negative divided by a negative is a positive, so you get 17/4. When you multiply or divide by a negative, that inequality has to flip over. I will put one like this on the test because a lot of people do not flip that sign. All right, homework. Only one section, I think. Make sure you finish 2-2. I did assign 2-2 homework, right?
Yeah,
Exercises?
1 through 5 or something.
No, that was just practice problems.
You finished 21, do 1, and then we did 2 practice problems.
Yeah, what was the homework for page 69?
27 to 51.
That was page 63.
I didn't get homework for 69 though. So page 69. I swear I did, but must not have. 1 through 17 odd. 1 through 17 odd. That should do fine. So page 69, 1 through 17 odd. And 2-6. Now 2-6 starts a little deeper in. 2-6 starts on page 94. Do all the checkpoints, except for any that have absolute value, those goalposts. If they have goalposts, I haven't talked about it, so you can skip those. And I won't assign any in the exercise.
What checkpoints are you talking about?
Practice problems. Practice problems. They're checkpoints in all my other math books. In here it's practice problems.
Do all the practice
Do all the practice problems, except for the ones with absolute values. Then on page 101.
What are you doing, man?
Page 101. 29 through 45 odd. 29 through 45 odd. Also draw the number line inequalities. A little short picture.